The life is short, so why not solve meaningful problems?
What keeps you motivated?
I get the most of the satisfaction of creating something. Because if everyone has the same problem, then you build a solution for that problem.
What is your secret?
There is no secret or there is no silver bullet.
What patterns did you see to make that bet?
There are quite a bit of similarities to early days of the internet. Networking will be strongly coupled with the computation. For ultimate AI success, it's necessary to be reliable. Sometimes you are lucky, sometimes you are not lucky. So the main thing is about how you react to those.
What do you think the next 10 years in AI are going to be about?
You see, it's an unfair question because...
Welcome back to the second episode of AI Founder Journey. Last time I was delighted to host Eric Schmidt, and today I'm hosting another legend, Jon Stoica. Jon started and scaled a company from $0 to $62 billion. I really enjoyed this conversation, and I really hope that you enjoy it as well. Hi, Jon. Thanks for coming here. Very excited.
For having me.
I'm very excited to have this conversation. As you know, you've been like a godfather to me. You've been a great mentor for me since my PhD at Berkeley, my manager at Anyscale, an advisor in my company. I've been following you and working with you as close as possible over this journey. So thank you for that. To start, I would love to hear an intro from you. How would you like to introduce yourself for our listeners?
Well, I am someone who tries to work with smart people like you.
Thank you.
I think, obviously I've been in academia basically all my life after I did my PhD. And I think at the core of it, I really want to solve problem I'm passionate about, and I was lucky to be able to do so. So whether it's in academia or in industry, it's the same thing. There are various problems at a given time, maybe which are driven by various trends in the technology. And, these are the problems which, if a problem passionate you, should go and after solving it. So I think that's kind of at the core. Of course, I've been academia, doing entrepreneurship, and I really, the entrepreneurship, most of it was around open source. So that's kind of defined my career so far.
Mm-hmm. Yeah, that's great. So how did you determine at some point that the problems you're going to solve are going to be problems you're solving in academia, and then at some point you want to take that and make that into industry? What inspires that?
I think solving the problem has different phases in general. It has more a conceptual phase, something like more of a if a system prototyping phase, proof of concept, so to speak. And that works very well in academia. It's the first thing when you solve a problem, it's a phase of exploration, right? What is going to work, what is a promising approach, and things like that. So exploration, in general, it's academia, it's a good place for it. Then once you are on a good path to solve the problem and it's pretty clear how you are going to solve, then it's more about exploitation, right? If you do analogy with reinforcement learning. So then you are going to try to push on that approach. And in many cases, and we have been successful at Berkeley, again, having many great students like you, which basically, can go quite far in building artifacts, systems, in particular open source, who become quite popular and are used by many companies. And there are examples all the way from Mesos and Spark and Ray, more recently VLLM and so forth. And then at the point, if you want to continue the growth of that solution, of their system, then you need more resources. And that's a good time to transition, maybe from academia and industry. But the key thing is also obviously is down to, having, team of people, researcher who are really excited to take that, what they've been building in academia and out there and push for it.
Yeah, you quite had a lot of successes among your students. A lot of people keep asking me how come like young students are always like either successful entrepreneurs or professors. So you mentioned a lot of open source projects, a lot of companies, but what do you think? What is your secret, or what is the secret sauce?
That's more a question for you because you are the observer from outside. I think it's obviously it's a lot has to do with the students. I am from that perspective. I am an enabler, right? I am there to help the student be the best she or he can be, right? And this is not entirely altruistic because successful students represent also your success, right? Just and I think it's about I'm trying to inspire them to work on to aim high and to in some sense to be ambitious. The life is short, so why not solve meaningful problems? And also surround them by with a strong team and strong role examples about other people, maybe a little bit more senior students who have been successful. It's always the easiest is to learn by example. It's much easier to learn than reading a book. Yeah. And then hopefully provide them with an exciting environment where they can find many exciting problems to work on, right? Yes. Because at the end of the day, the students, like everyone, like myself, have to be very passionate about working on a problem because then they are going to do their best work.
Yeah, as an observer, you can say you work very hard. We've had meetings on weekends. You set a great example for ambition. You had a lot of successful projects, so you're not impressed easily.
Yeah. So I have yet to see someone who has been very successful, whether in academia or in industry, who hasn't worked very hard. Well, no matter how smart they were or how lucky they were.
Yeah, you're always bullish also on execution. Execution is everything.
Yeah. I think that, let me give you an example here. It's like maybe many people relate. So many people will ask, okay, what it takes to be successful, right? For instance. Actually, that's not that hard. There are many books tells you how to be successful. I'm sure that if you go here on the street and you ask a few people, they are going to tell you, it's like, you need to be focused, not distracted, work hard and so forth. Maybe some of them will say be a little bit lucky and so forth. Now, the next question, if you ask them, how many of these things you are doing, it's like you'll see that many of them, they don't do these things, although they know that what needs to be done. Maybe something which relates to other people is about losing weight, right? It's like kind of knows what people try shortcuts to do it to make it easier to lose weight and so forth, but like fundamentally it's it's less, more exercise and things like that. So people know, but why they don't do it, right? Because it's hard, right? So it's not because you don't know it, and because it's hard. So that's part of the execution side. Another reason the execution is very, very important in my mind is that if you have an idea and if it fails, and most of the idea fails, it can fail in general because of two reasons. One, because the idea is bad, right? But the other one is because the idea maybe is better, but the execution was bad and it still fails. So now, if you cannot execute well, you cannot differentiate between the two, right? I mean, it fails, so execution was bad, but doesn't tell you much about the idea. The idea could have been good, right?
Yeah.
So you cannot draw that conclusion. So it's you iterate much slower. You kind of move slower.
Yeah. How do you distinguish between the two? Like, how do you know if you're executing well or not?
Well, you never know, but executing well, like it's. So it's the other way. It's sort of the other way, right? It's like if you have an idea and it was successful, so presumably both the idea was good and the execution was good, right? So at least you have some instances, and that kind of tell you what a good execution means if you have seen some ideas which have been successful, right? That's what it is. But it's it's not easy, but you'll figure out,
Yeah. Well, one of the great advices I got from you on a similar topic to improve the execution in a way is that we're always dealt like a few cards, and you cannot look at other people's cards. You can only look at yours, and you can only choose cards that you already have to maximize reward in a way. Reinforcement learning, speaking of that. I guess honestly, I didn't think that way before I met you, and it took me a little bit a while to understand that. But once I adopted that and I understood that, it's like a no-brainer. Like, it's obvious. Like, isn't it obvious that is the case? Yes. What sparked that thought for you, or that learning, or how did you get to that thing that at some point you realize this is how life is? And what other
I'm much older than you, so I had you have people basically saying, I was not successful, I am not in a better spot because I was unlucky. Or, people say, oh no, this guy was doing so well, but he has so much luck. And I'm not saying sometimes this is true, but I think in a lot of times it's like following thing. It's like everyone has moments when it's lucky. It's a stochastic process. Sometimes you are lucky, sometimes you are not lucky. So the main thing is about how you react to those, right? Because if you can make the most of the situation when you are lucky, when you get a break, and you can minimize the damage, so to speak, when you are unlucky, clearly you can see that you are still going, everything being equal probability you are lucky or unlucky, in times you are going to be an ascendant slope, right? On the other hand, if you are going to get yourself, dominated and depressed when you are unlucky, and you are not prepared to take advantage of the situation when you are lucky, clearly you are not going to be on ascendant slope. So what I'm trying to say is that the way you react to the events, the way you are prepared when you get, so to speak, a break, it's extremely important in defining your trajectory, professional in life, right? I actually, like Pasteur, right, was saying is that the luck favors the prepared mind, right? Basically, like if you are prepared when you slack, you can take advantage of that when you have some break. So this says that you need to focus on how you react to this external input. So this is the only thing you can do. Therefore, it's with what you have to play the best you can do, right? That's what I mean. You have some cards. Everyone some cards. Sometimes you get bad cards, some good cards. But the good players are going always to try to exploit what they have, right? It's, the fact that you are unhappy because, you are unlucky, it's human, right? But logically it doesn't help you.
Right? Yes, it doesn't. It's a very interesting thing to learn, but it also requires a lot of resilience to to keep going. And I guess what keeps you motivated? What keeps your energy high? Like you're a professor at Berkeley, you have multiple companies, you keep going, and I'm sure there's lots of ups and downs. So
I think, yeah, that's a good question. I think at the end of the day, different people are driven by different things. But a lot of people are driven, I think that as a human, I think what it's drive many people, it's kind of the act of creation, right? You create something, right? And I think that also drives me, right? It's like something, again, I get the most of the satisfaction of creating something, right? That something is that it's about, hopefully, again, can help us solve a problem, has an impact, and solve a problem other people care about, right? Because we are human, right? It's like social animals, right? We care about what other people care about you, and you can make people care because you build something which in some way makes their life easier, right? Job easier, right? That's kind of keeps me going. So that's kind of, always here. That's the most satisfying moment. You get something that you created something could help other people. And it's, again, I don't want to appear here very, super altruistic or something like that. But again, if it helps other people, it's like you feel lots of more satisfaction because, people are going to recognize also your contribution.
Yes, yes. Speaking of the creation, if you look back in the few years, like you started with the first bet on data and DataBricks with Spark and DataBricks, and then a few years later on Anyscale with the compute. And everybody knows today that compute plus data is what fuels AI. But you knew that like many years ago. I guess, what patterns did you see to make that bet? And what do you see now that maybe we can make another DataBricks in there?
Yeah, I think when you are doing something, no matter what you do, there are things which depends on you, like the cards, right? The analogy, of what you have the cards. It depends on you how well you are going to play your hand. And there are things do not depend on you, or you can have much less impact on them. And these are like the cards you get, right? So you want to make sure, though, that therefore that you are on the right side of the major trends, secular trends. Because this is one thing it's very hard to change, right? So that's so it's worth to think a little bit about what are these secular trends. So what is the space you want to act, right? For instance, it's like what game you are going to play, right? Pick what game you are going to play, hopefully with your strengths and everything, you can win more often than losing. So, so that's was the thing. So for instance, and I can tell you a few, I can have a few examples here, even some of them which are not successful and some are more successful and so forth. Like when I done the work after coming to Berkeley very soon, peer-to-peer networks, right? A lot of people working on peer-to-peer at that time. And it was driven by companies like Napster, Nutella, distributing content over the internet, more or less legally or illegally. But that's not the point. But the assumption and the trend of people were saying then, it was that, why do you do that and why is that a problem worth solving? It was a very interesting problem, but not distributed, all of this great stuff. But the assumption was that it will be people are going to distribute more and more data over the internet. Soon, video will be distributed over the internet. and then the internet will not be able to keep up. Will crash and burn on everyone who will send their videos over the internet. So therefore, the peer-to-peer was supposed to solve the problem, because instead of getting the data from the servers at the center of the internet, right, in the backbone, all the way to you, you can get the video from a neighbor, right? So the package do not go through the core of the network. It's only to the periphery of the network, right? It's like, it's like you don't, you go from one neighborhood to a neighborhood in San Francisco at the periphery instead of going through the downtown. So that's kind of the assumption. And a lot of funding and things went into that. The first company we co-founded, Conviva, that was a problem trying to solve. But then you see that after 2 years, 2 years, and so forth, is more and more data is transferred over the internet. But actually, things do not, internet is still doing well. Actually, the number of failures and so forth is not growing, right? And then you see also the price, right? I remember initially, it was 2006 or something like that. The price of transferring 1 gigabyte was, 40 cents. And then in 2 years, that goes back like a few cents. Yeah, so you see that you made the wrong bet, right? Now, okay, so that's, no matter how smart you are, how good your algorithms will be, who cares? It's so cheap to, to just transfer from then these content distribution networks. Then, basically what I'm trying to say is, it's a lot of effort, a lot of smart things done there, but it didn't really matter at the end. It was the wrong. So, and in those cases, I think it's important to recognize when you are wrong, right? Now, with the data, I think when we started DataBricks, the pattern was clear. By the way, always you make a bet, right? It's like, because, things are not always clear, right? That's why it's otherwise everyone will do this, will make the best decisions ever. So with the data, it was, there are enough signals. So the question is, are you sure that this will be a secular trend and you can bet on it or not? So what are the signs? Obviously, then cloud, it was Hadoop. Hadoop was very popular. Cloudera and Hortonworks, the startups behind Hadoop, were the darlings of the investors. And when you look beyond that, you look at the fact that fundamentally Google and at that time, Facebook was a smaller company then, but they get the value from their data. That's why Hadoop, it's MapReduce. MapReduce was invented at Google, right? So then, okay, if these companies get so much value out of their data, every company has their own data, especially if they have users and so forth. So clearly there is a lot of potential to get the value out of data, getting insights, improving their products, coming up with new features, maybe new products, new services, right? Improving productivity, right? So it was pretty clear that you can, there is a path forward because you have kind of examples, right? Which you saw that, could be replicable, right? And then it wasn't because there are so many companies, so many business models, so many use cases. It was not very likely that you have only one solution for everything. So therefore, building the best tools for analyzing large amounts of data seems like a good bet, right? Because if everyone has the same problem, then you build a solution for that problem, and you nail it. And then with Ray and Anyscale, it's again the trends was obviously it was the demand of ML, AI, deep learning at that time, growing much faster than capabilities of a single node. So you need to do something. You need to run all of this workload distributedly. In addition, in order to bridge the gap between the demands and capabilities of a single node, people also started to use accelerators, GPUs, right? So now you need to run not only on a distributed system, but a heterogeneous distributed system. So, and if that was to continue, then again, it is very hard to do it. So building tools which makes that easier, reliable, more reliable, I think seems like a good problem to solve, right?
Yeah. In hindsight, yeah, it looks like clearly for me. But okay, so moving forward, what are the trends right now?
I think moving forward, I think that two trends I would bet. So one, it is again related to the systems. You are going to have more and more these systems which are going to be vertically integrated across the stack. So basically, you are going to optimize across layers. They are not going to be separate. Like for instance, networking will be strongly coupled with the computation to do fine-grained operation, fine-grained overlapping of compute and communication, things like that. And fundamentally, the reason for that is because running these workloads is extremely expensive, and obviously, performance is always important. So that's why, like for instance, if you look at the cars, if you want to build the fastest car, like Formula One, it's like very vertically integrated, right? Everything has to work together, right? So in some sense, it's also going back to supercomputers, right? People, built decades ago these supercomputers, and they were bespoke, also vertically integrated, but the same reason, right? You want to have ultimate performance. And you have then commoditization with the PC and so forth, economy of scale. But now we are going to go a little bit back. But the difference is that for supercomputers, maybe there are not as many, workloads. You have simulations and you have maybe weather predictions and whatever. But now for this machine, AI, it's almost, you have all the use cases, right? So you have much more, you can, the use cases you target are much wider, right? So it's, I think that's how you get it back to this supercomputer kind of era, so to speak. So it's vertical integration. The second thing I will bet is about, I think that work on AI reliability, right? It's like today's, AI is, AI is doing a lot of things today, right? But at the end of the day, I think that for ultimate AI success, it's necessary to be reliable, right? It's like, and the more valuable the use case, the more reliable in general you want to have. To be. Right now, the most successful AI applications are when the humans verifies or is supposed to verify the outputs from these large language models, or agentic systems, code assistants, right? The code assistant suggests you changes or new code, but you are supposed to click and approve, and you are accountable for it, right? If you mess it up, right? It's not the AI. The same customer support, you have a problem, you ask customers, service implemented by AI, and it's going to give you a suggestion about how to fix your problem. Check whether your laptop, your machine, your computer is plugged in, right? And you can check, and they say yes or no. So so I think that's kind of, or you can, like you've done some work, you can use AI in cases in which for sure that the outcome, the output is correct, right? You have strong verifiers, like designing circuits, right? Designing circuits, you have a lot of tests to say the layout is correct and things like that. So in that case, you have AI proposing new layouts and so forth, because you can verify the correctness at the end. In this case, AI is more about optimization. You've done the work in compiler optimization and things like that, using reinforcement learning many years ago.
Yeah. Well, yeah, absolutely. It's the reliability in AI is a very hard problem. Everybody now is building wrappers, and these wrappers just need a lot of evaluation to get the accuracy over there. But is there any secret to getting this reliable system? And also, if you have multiple agents, how do you compound this?
The secret is that there is no secret.
The secret is there's no secret.
The reason I'm thinking it's hard is at the end of the day, it has also to do about, how can you make sure? One way to make sure is you have a very clear description about what job you want to be done. And then also very precise verification, maybe based on the description, that the job has been done satisfactory. But that's hard, because precise description is hard, right? It's like humans. When I say there is no secret, or there is no silver bullet, it's like humans, right? It's like the managers who are the most effective are able to be pretty precise and very clear about the jobs the people who report to them they must do, and what represents the success, right? What are the criteria of success for that job? If you are wishy-washy, you are not going to get much, right? So it's the same thing, but it's hard, right? It's hard to be precise. It's hard, it's so I think that's it's very hard to get around that. And there are solutions, right? It's like formal verification, right? Say programming. Formal verification, if you have a formal verification, then you can generate the solution, generate the code, and the proof that the code is correct.
But nobody in the Bay Area right now, and the AI companies.
But again, writing that specification is extremely hard, right? So I think that this is a progress. Is about if we can learn how to write better specification. Maybe here the AI can help us to debug, to poke holes in the specification to be better and better. And then from there, also verification of these tools. I think that's the progress will be. But again, it's not really a silver bullet, right? It's not. It's still hard work at this point.
Yeah, it definitely made it much easy to build demos. And there's a lot of nice demos. But when you look at the products, it's not great.
Because it's a fundamental difference between a demo and a product, right?
Yes.
Yeah, a demo, there has to be an instance in that particular use case you are addressing, which is really impressive, right? That's a demo. One or two, right? It's really work. And that's a good demo. But in the product, all this everything should work every time, right? So it's not only one example. All the examples should work, right?
Yeah, it almost seems the way it's being done is that people are just creating these roles. Okay, for this question, this is the answer. It's like evaluations, and they have all these rules engines from the past now are just becoming checks, and if it passes these checks, then like it's good. But then
Yeah, it's incomplete testing, right?
yeah, but is there any other methods you've seen people doing, or okay, there's fine tuning, but at the end of the day, there's nothing that constrains it to be as comprehensive. You can always find.
Yeah, that's why I think it's going to be a lot about the use cases. But of course, for instance, if you have a piece of code, you can do better code coverage. You can do fast testing and so forth to see that you have an input which triggers every code pass. It's maybe you can never in some of these cases you can never be absolutely sure. But it's different if you are sure in 99.99% than versus 80%, right? So I think that for every use case, you are going to see, or for every task, there are ways to do it to improve the correctness. Now, the question it's about is like, are you going to have 100%? In some cases, it is possible. In some cases, it's not. It's very hard. I will never say it's not. But it's another thing about verification, which is extremely important. And specification. It's this. If you have something, a task which is well specified, you can make much quicker progress. So if you think even in the history of humanity, if you talk about sciences, it's much more rapid progress, right? If you compare with 100 years ago or 200 years ago. And one of the reasons is because you build artifacts, or the physical or logical artifacts, which is very clear, very well specified. It's very clear what gets in, what gets out. So you can compose them, right? And this is engineering, right? I can build a car by assembling some wheels which are well specified, and kind of dimensions, and engine. You can put all this together, and you have something end to end which is really working. But each piece is very well specified, right?
Yeah.
So you can build, right, these things. But if you cannot do build, you have this kind of reuse of existing artifacts to build bigger artifacts. In some sense, this gives you some exponential development speed. The same with software, right? You have libraries, you put them together and so forth, or different services, right? It's this composability. If you don't have that, it's much harder to progress. Like for instance, literature, right? It's like if you look at literature today or 100, 200 years ago, it's not the same kind of huge jump, right? So that's kind of, and maybe my take, which can be wrong or not, is that it's much harder to compose.
Yeah.
Right? You can compose them, but then it's not legal even, right?
Yeah.
And probably you're not going to get something very interesting either, right? Yeah. But I think that's kind of, and the last point to make is that even if you think to look today at this with reasoning models and so forth, where is the biggest progress, right? For tasks which are much easier to specify and check their correctness, or it's like problem solving, coding, because you have testing. It's not complete like you said, but still better than for other tasks.
Yeah, I mean, sometimes it's even harder for us humans to specify exactly what we want.
Oh, absolutely. You don't know what you don't know.
Yeah, it's hard. But
so this is where maybe AI can help you. Telling you, it's like maybe hey, what happened in this case? So, maybe you didn't specify here. This is vague. You have to specify, right?
Yeah. Do you think some form of memory, which is what a lot of people are working on, would help with that? Or preference?
Yeah, memory. It's already many services and systems are using memory. But again, memory is just enhancing your ability about what to do, not always enhancing also your accuracy. How you can do easier and faster many things, or you can do things maybe you couldn't do before. The question, how much it can help you with doing things you were able to do it before, but do it far more accurate. Maybe it helps.
Mm-hmm. Yeah, a lot of the successful use cases that I've seen, the AI agents are mostly being used as orchestrators. Like all these companies or enterprises already built the basic blocks, the rules or whatever, and now you're just orchestrating it. I feel like that makes it more deterministic, at least, than having totally. Okay, have this tool, use it, instead of trying to do what the tool is doing.
Yeah, and the point that it's again, there are things which humans are easy to spot, but some of them are not. Like for instance, if I ask for a bar graph and gives me, I don't know, a pie chart, I can say that's wrong, right? Yeah. But if some numbers are a little bit wrong,
yeah,
right? I don't know.
Yeah. Do you think MCP, the model context protocol, is trying to help with that? Basically, make it so that each one of these APIs has a standard way of calling it, and it's open source. Are you betting that this is going to be the framework? Probably makes sense, but do you think the one that is currently the one that was released by Anthropic in November is the one that people should be building on top of?
And I think it's certainly a step forward. The reason I am hesitating here is that, again, pattern matching here. Typically, you get very good APIs after you have build a few successful use cases end to end, and
vertically,
then you can see what is common and what is the natural decomposition, and then you are going to try to figure out the right API, the right interface. But I don't think we are at this stage with the current agents, right? So therefore, I don't know. So it's like when we are going to have maybe in 1 year, 2 years, a lot of more successful instances of agents, really successful, like you mentioned, or more work for some use cases almost all the time. Then now you have an API. I think that will be, you're much more confident that will be an API to survive for the years to come.
Looking at the wrappers right now, what it makes the differentiation? Like everybody is building all of the, like it's very easy today to build a very simple application. There's a lot of companies, by the way, out there that have a lot of success with mostly wrappers that can, in my opinion, easily be replicated, but they were first or something like that. Like, where's the innovation there? Or like, how do you make this sustainable in the long run?
Yeah. I was talking with someone about this, and I think this is definitely, I think it's not unlike, from my perspective, there are quite a bit of similarities to early days of the internet. So in early days of the internet, you have a huge number of applications for everything. And also the rule of the game there is to get as many users as possible. And hopefully you are going to find a way to monetize, right? The difference now is similar in that respect. But there is one good difference, one big difference, and positive difference. People pay for it. And maybe that's because ChatGPT asks people to pay for it, right? $10 or $20 per month. But there is a question, like you said, if a group of smart people, they can get a huge revenue, in short interval of time. Um, in many cases, the question is that, okay, so wouldn't the next group of smart people also having the insight of what the other people done can replicate it, right? Why it's hard to replicate, right? And that was the thing with the internet as well, right? So I think that to answer your question, and there will be some of the companies which will be absolutely successful and generational. Like with the internet, some of them will fail. But I do think that one thing which will choose the winners from the losers will be the business model. Right? That's what it is. Because if you think about Google was coming in a long line of search engines. It was Lycos, Alta Vista, whatever, and many others. Yes, their technology was better, but Google really became a big company when with AdSense, right? Which was different from what other people have done before. Because yes, their search was better, but what they tried before, I remember they were doing one of their first product was a box, a yellow box. You put in for the enterprises to do internal enterprise search, right? You get the box, you put in your data center, and it's going to index your documents within the enterprise, right?
It's the same what people are doing right now with an internal search with LLMs.
So, but this is what I think, right? Even with DataBricks, probably one of the things what, at least for an open source based company, was just doing and going only as a service, right? It's a cloud service and charging for that, right? So before, like, it was this open core model, you pay a little bit for the software, you pay for the support and things like that. So, but I think that's kind of, even with Amazon, right? There are many, and by the way, execution was also the key, right? But Amazon then when you have Prime, right? It was an inflection point.
Mm-hmm. How do you differentiate in a business?
Or AWS with AWS, right?
Yeah. So the business model differentiation, how exactly do you differentiate there? It doesn't seem like a technology or like it seems like more like you try a bunch of things.
I think in many cases it's about you find the better alignment between your cost and the value you provide to the customer, but a better alignment to the value you provide to the customer. Like pay as you go, huge innovation, right? It's more aligned with the customer. The adoption, like AdSense, right? More aligned with many, and actually co-opting a new market, right? For the ad industry, right? Because before, all your ads, it was, I remember someone telling me, it's like, you go, you meet twice per year in this kind of fancy dinners and so forth, and you make the deal about. But now, allows everyone, right? So it's now this kind of capture a new market, right? Yeah. So I think this is kind of the stuff. You capture a new market, and because you align better with the value you provide.
Yeah.
But it's not easy, obviously.
It is not. It's not. I do want to build a generational company like DataBricks. And to your point, yes, there's the business model, there's making the right bet. What other things you have to make sure are in place to build a good foundation for a company like DataBricks in this time?
So whatever I'm telling you, it's not statistically significant, right? I have only a very few examples, right? It's like very high error bars. And in retrospect, it's easy to say, oh, we did X, Y, Z. Obviously, they are good because the company is successful, right? It's like, so in general, you shouldn't confuse what you have done with the outcome. You can have done all the right things and you may still fail, right? Or you can have done a few strong things and you may still succeed. Mm-hmm. So I think with DataBricks, I think it's, there are a few things which we did and or harder, like betting only on the cloud and not focusing on prem. I think that's one, clearly. The fact that initially only we are focusing on data scientists, which was debatable even among us in the company, when data scientists there are not many of them. So there are a few things like that, but if we saw that we are betting on the right trends, that the number of data scientists will explode, that the cloud market is going to grow much faster than on-prem and things like that. But there are a lot of being at the right times, and some of the competitor maybe you can argue that mis-executed, right? So you got a break. So many things happen, but clearly I think it's it's down to the execution, and obviously Ali has done a terrific job leading the company.
Yeah, you did manage to get a partnership with Microsoft, which is huge early enough, and you've had a lot of successful early customers. I guess, how do you land that today? Like, let's say today I want to go get a partnership with Microsoft at this early stage, or I want to get like a lot of the successful customers you've had. Like, how do you justify to them why they should even entertain that, right? Like when you're early on, you
like
don't
with every, like early on is like, it has to be a value on both sides, right? These are the only partnership which matters, and hopefully it has to create additional value so both can win, right? That's kind of the rule. And there are the partnership are bespoke in general, right? It's like, so obviously Microsoft wanted to have a good data solutions around Spark. They had something around Hadoop. I think it was called Hadoop Insights, if I remember correctly. And, that's kind of, they try to do. We had DataBricks best solution at that time on the market for Spark. And why they wanted to do it? Because they want to sell also more compute, more data, get more data, so increase the net revenue for Azure, right? And get new customers who value data analytics, and they didn't have at that point a good solution, right? For DataBricks, obviously, it's again getting access to more customers, enterprise customers, help with sales from Microsoft Salesforce, right? So, but again, the main point I want to make here is that it's not a zero-sum game. If you do the right partnership, the pie can increase dramatically. So each of the partners is going to win significantly.
Mm-hmm. Yeah, makes a lot of sense. It's easier said than done.
Yeah, absolutely. It's very hard. Also, the partnership are hard because the humans are involved, right? And it's emotion, it's everything.
It is.
Right?
Yeah. Okay, just maybe one or two last questions. What do you think the next 10 years in AI are going to be about?
It's an unfair question because ChatGPT happened, less than 5 years, right? It's like less than 4 years. 4 years, right? So how can you know? I do think obviously you are going to have more and more tasks being done by computers better than humans. I don't think that, I don't think you are going to have this kind of very dangerous AI, which, I think humans can make it dangerous in their human's hand can be dangerous, but by itself, I don't think you are going to have this huge, extinction level events caused by AI. Other than that, clearly will help with a lot of productivity. I think that of everyone, I think obviously it's going to make some jobs, professions, so to speak, redundant, but that always happens with the progress, with the technological economic progress, right? It's like that's always happened. So I'm not saying anything insightful here, but the truth is that, I don't think it's going to be very bad. I'm very optimistic about AI. I'm on that side.
Yeah. And some of our private conversations, you mentioned that in the open source world, China is either ahead or about to get there. You also mentioned that the US.
I think there I would say the following thing is that if you look at about the past year, obviously Chinese open source models have made huge strides and close the gap. They are the best model at this very time, and it's not only one company; it's 2 or 3 companies. It's DeepSeek, we have Qwen, and things like that. A few models which are best than the rest, and they are reasonably close now. Than some of the proprietary models, exceeding the capabilities for some of the, pretty popular proprietary models. So now if you think about and you extrapolate, right, what will happen next year if nothing changes, right? If things remain like today, they are going to, I would guess, catch the best proprietary models, let alone the open source. Other open source models. The other way to look at it is about what do you need to build these models. You need 3 things. You need people, you need data, and you need infrastructure. And China have a lot of AI experts. So they are very competitive, on the first bullet. They have data, no question about that. They have less, legislation is more permissive, so they get more data.
More permissive than the US.
So it's the only thing is infrastructure, what we are seeing with export control and things like that. But I'm not sure how things are going to play out there and how effective it's going to be. I also remember that when I was in Romania during the communism, there were export controls for the later generation of Intel chips. And I remember people still had access to those. Again, maybe things are different now, but that's kind of, so if you triangulate from the trends and capabilities, it's a natural conclusion.
It's a very similar conclusion to what Eric Schmidt mentioned in our last conversation.
And I think I would add, like, one of the problems here is that when we talk about the people, the diffusion innovation in China is arguably stronger than the US, which has used to be the US one of the strongest advantages. Because it's more open weights, and it's a much stronger collaboration between academia and industry building these models. For the United States, every lab, it's a silo, and there is very little collaboration, open collaboration between academia and these labs, unless you go there and you spend time there as a faculty or a student. So therefore, you cannot, in US right now, you cannot use your entire human resources, talent, efficiently, right? Right? I mean, academia doesn't have much access to resources and things like that. So I think that's kind of one problem. The diffusion of innovation in US is mainly people from big labs starting new companies or moving from one company to another.
Is there anything you think we should do to change the trajectory?
Definitely. I think we should. The only way you can. There is only way you can solve one. Well, no, maybe the only way. Maybe there are people which are more creative than I am. But one way to do it, it's how you are going to get all these people working together to speed up the advancements, and your competitive position is they need to work on shared artifacts. And when you come to shared artifacts, you need basically open source. It's a great vehicle, the great shared artifact, and the other one is infrastructure, right? You need to have some shared infrastructure for these people.
Yeah, but if all of that is open source, then also China can access it. So how does that?
But the point is, if China is doing a better open source than US, it's about the rest of the world, right? Right? Which model is going to use, right?
The infrastructure that people are building on top of.
Yes, software infrastructure.
Yes.
Right? Right? It's again, it's a great thing what happens. It is, this competition, right?
It's good.
Clearly, it's
pushing people.
I think it makes human civilization progress faster.
Yes.
So at the end of the day, it's positive.
Let's say we bring a group of people, and now we have people in their 20s that are gonna bet on something in AI. What would you advise them to bet on, or what a big problem or opportunity would you?
Yeah, well, I said earlier, right? It's like if you are more on the system side, it's kind of vertical integration. I think that you did a little at your PhD, code generation and optimization for different hardware and things like that.
Yeah, we made
doing automatically.
We made the wrong business bet that we will sell it as a compiler instead of a code generation engine.
So that's kind of one, and AI reliability.
Yeah, reliability. Okay, Jan, thank you very much for coming here.
You're welcome.
Very excited to talk to you and continue our conversation later. Thank you very much.
Thanks for having me.